2 সরি 7টা 2 আমি করে দেবো, এই পরেরটা তুই করে দিস।
নাহলে প্রিন্টারটাকে অফ করে আবার অন কর। হয়েছে প্রিন্ট? এটা তো এই যে আমাদেরকে বলে এখন অব্দি আমাদেরকে একাডেমিক থেকে দেওয়া হয়নি আইডি এই মাসে। হ্যাঁ, এইসব নিয়ে কেউ দেখে, ততটা এমনি সবাই জানে। আমাদের ডিপার্টমেন্টের লোকেদেরকে বোঝা যায় না। হুম। কি প্রবলেম আছে? তার সাথে আমার কোনো কথা নেই। তো বলো না ব্যাপারটা কি? We will be starting the session in about next 5 minutes. Wait for others to join.
Okay, sure. उसको अजीब सा ठंडी लगती है इतना टाइम नहीं बैठ सकती मैं हाँ यहाँ पर एक्चुअली सफोकेशन है ना कुछ बोलते नहीं है ना नहीं तो अगर ये खोल देते विंडोज विंडोज कोई जरूरत ही नहीं जिल्हा संघटने गुजरातीમાં
Okay, so we will start our live session now. I will start by introducing myself. I am the TA assigned to this course on integrated waste management for a smart city. So currently I am doing my PhD in IIT Kharagpur under the supervision of Professor Brajesh Kumar Dubey and Professor Makaran Madhav Dhandre. So today I can see that only one participant, it is Astuti, has joined, and others, I hope that they will join in the meanwhile. Today, like other live sessions, we also have 15 questions, and almost like I think all of them are theoretical only. So I guess we can quickly go through them. In case if you have any doubt, any query in between, please feel free to interrupt me at any time, and we can go through any particulars that you feel necessary. Okay, just give me a minute. Okay, so the first question. So the question is excess air combustion of solid waste is done for which of the following purposes? And your options will be Okay, so these are your options. Why excess air is provided during combustion of solid waste? Yes, option 3 is the correct answer, to ensure complete combustion. To aid this point, you can see in this particular slide, I will maximize it a bit. So, as the name itself suggests, excess air means that we have supplied more air, more oxygen to be precise, than the stoichiometric amount that we derive usually by the equation. For example, if you have some carbon, let's say 12 kg of carbon, and then you need some amount of oxygen to convert it into CO2. So that molar mass of oxygen that is required, we provide around 120 to 200% more oxygen than it, and that oxygen is provided from air. So based on the percentage of oxygen present in the air, volumetric wise uh, and mass wise, we determine how much air should be uh, sent to the combustion chamber. So this was the first question. Then moving on to the next one, it is based on leachate and is a colored liquid that comes out of which process? Okay. Okay, so you have said options 3, that is compost plant. Fine. So compost plant, yes, it is true. But traditionally, when we study solid waste management, if you have got such options 4 and you have been asked like liquid leachate is coming out from where, uh, you have no other option for choosing 2 or more of these processes, then it is better that you choose sanitary landfill, because we know that landfill, it is designed like we have a leachate collection layer at the top, at the bottom, then other liners are also there to prevent the this permeability or the seepage of leakage into the groundwater levels. So traditionally or most commonly, we know that leachate is generated in landfill, because whenever there is rainfall or something like that, so the water, it starts seeping through all the wastes and then it starts collecting at the bottom. So that leachate, you as you already know, it has got huge organic loading and other dissolved contaminants. So sanitary landfill is one option, and as you have correctly mentioned that composting plant, they also generate leachate, because leachate is basically anything that a liquid that leaches through something, and what is found at the bottom, that is leachate. So as you have correctly mentioned, compost plant, from there also leachate is generated, which is sometimes also known as composting leachate. So in this particular question, both sanitary landfill and compost plant both can be the correct answers. But in case if in examination you have been presented with only these 4 options, I will suggest that you go for sanitary landfill. But ideally speaking, both option 2 and option 3 are correct. And in compost plant, how is leachate generated? Because sometimes we know that to maintain that optimum moisture content, we have to sprinkle water at regular intervals. So those waters, they seep out to the bottom of the these composting units, and then they are collected as composting leachate. They also have a huge organic loading. And for example, if in our campus, the compost is being prepared from your yard wastes like trees, like tree leaves and everything like that, along with the food waste. So what happens is that in food waste, we know that almost every dish we use salt. So that is why when the leachate is formed, we have observed that it has got exceptionally like high levels of chloride ions, sodium ions are there. So that is clearly indicative of the food waste being used for preparing the compost. And apart from that, it has got a huge COD as well. And the pH of the compost thing leachate that is collected in our campus, it was around 8 or 9, somewhere like that. It was alkaline in nature. And what happens is that the people who are generating the this leachate, they sometimes use that leachate in a diluted form as a liquid fertilizer. So that is one way of using it, and in that way we can also promote that circular economy concepts, valorization of waste streams like that. And otherwise, if you look into if you Google it, you will find that various units, they see compost leachate as a nuisance, and then they try and do research on different ways to reduce its organic loading like any other wastewater treatment. But the extent through which it is treated, it is much more, because traditional municipal sewage that is generated, it has got a COD of around 300 to let's say 700-800 milligram per liter. But this composting leachate, this can have more than 5 grams per liter of this COD, or 5,000 milligrams per liter, more than that. So that is regarding question number two.
I have a question on composting.
Yeah,
So, if composting is done on an in an organization basis, or maybe by as a plant, in
yeah.
that case, at the very end, you increase the temperature so that uh, all the bacterias are dead.
Hmm.
So if it is being done locally and in a household,
Hmm.
so in that case, is that a mandatory activity, or is it just an
Yeah,
optional?
no, like traditionally speaking, if you don't, like, what happens, as you said, the temperature rises, and then in the commercial ones, we mix it at regular intervals so that again the air comes in and then the temperature falls down to mesophilic range. So in households, as you correctly mentioned, like we have a bin system. In case if people are not mixing it again and again, compost will be prepared, but the quality, it will be inferior to the ones that is commercially done, provided that both the things, both the feedstock and everything, both of them are identical for household composting and one that is taking place commercially. So ideally, this regular mixing, it should be done, and if it is not done, the quality of the compost, it degrades. Reason being, the this useful bacteria which help in composting, they mostly perform in mesophilic range. So once it reaches thermophilic range about 45 degrees centigrade and above, in those ranges, some of those useful bacteria, they start to die off. So it is very important that such high temperatures, they are not maintained for a long time, and whenever it happens, it should be mixed immediately.
Okay.
So moving on to question number three, it is based on phases of combustion. So there are four phases of combustion, and among the options you have to choose one that is not included in one of them. Okay, so in this particular question, I will share the slide with you, which will reveal that option three is not the correct one. Like, as per this question, you have to choose an option which is not among the four phases of combustion, and third option is that. So let me show you that slide. So as you can see here, when combustion starts, first is obviously the drying phase. The moisture, it goes off. After that, volatilization occurs, wherein the components of the waste which is having high vapor pressure, they are driven off. Finally, after that, phase three is the burn down of the solids. And after that, if you have some char kind of material, then it burns down. The combustion of char occurs, and after that, the bottom ash and other ash-like materials, they are generated and they are collected in the hopper that is at the bottom. And some of the ash, they can be like, which are not like there are two kinds of ash basically. One is the coal bottom ash, and then another one is the ones which are in particulate form. They are carried with the flue gas that is generated and then later on collected in, let's say, the bag houses or fabric filters or in electrostatic precipitators in those places, mostly bag houses. So these are the four phases. So among these four phases, you won't see like this condensation of vapors to liquid oil. This is not among the four stages of combustion, but yes, one that this particular part happens, condensation of vapors to liquid oil. It occurs if you, in case like you go through processes like pyrolysis or any other gasification like process, wherein the vapors which are formed, there is some amount of tar or other condensable liquids are there, and you want to retrieve them, then you pass them through a condensation unit, cooling units, and then you get the liquid oil back. So in case of traditional incineration, this is not considered among the four phases of combustion, because basically condensation is ideally not a part of combustion. It is a different process altogether. So these three and the other one shown in this question, burn down of char, these are the four phases of combustion. Now moving on to the next question, which is an assertion and reasoning based. So your assertion is,
I'm not sure of this. I couldn't go through the last week's session.
okay, okay. So actually, if you go through lecture 30, therein, and I think in slide 3 of week 8, there you will find the a more detailed solution of this one. Basically, both A and R they are correct, but R is not the correct option for A, and you have to go through that lecture 30 and slide number 3 of week 8 for a more detailed discussion. So I will see if I have something in here that is relevant. Yeah, this one. So I think these are one of few of those slides wherein you can see that it is already mentioned that fixed earth, it is one thing stationary, and another some points are it is used for smaller quantities of waste as compared to the rotary plane, which has got two chambers, and more larger amount of waste can be used here, and since the name itself it is rotary, so it rotates. So I guess you have to go through those slides and then you will have an understanding. So moving on to the next question, which is again a very simple one. Flue gas from incinerator stack includes which of the following gases? So your options are hydrogen sulfide and carbon dioxide, or carbon monoxide, or mercury, or all of the above. And you can see that this is the incinerator stack of, you can consider the solid waste from there. In here, the correct option will be Uh, yeah, option one is one of them, but in here the correct one is all of the above. Reason being, H2S and CO2, these are particular CO2, though we already know when carbon burns it forms CO2. H2S can be formed due to some sulfuric material, that is sulfur containing sulfurous material that is present there. When they burn, and sometimes there's lack of oxygen, then in those instances H2S can be formed, and these can later on react with the atmospheric oxygen to form sulfur dioxide and other components. After that, carbon monoxide in complete combustion, we know mercury can be, because mercury, as compared to other metals, it has got higher this vapor pressure, because anyways we know that mercury is liquid at room temperature, so that is one hint. So where does this come from? Like for instance, if the incinerator, it is treating your electronic waste, then those parts can have your mercury in some components, or someone throws in something else which has got mercury in it. So from there, these kind of metal based emissions can take place. So that is why all of the above. And apart from these three, some of the other commonly known emissions can be NOx. They are really very dangerous in depletion of ozone level as well. So that is one. And then based on some organic other hazardous pollutants can also be there, like fluorinated paraffins can be there. Then you have got others, what PCDDs and PCDFs, they are also there. So these are basically man-made artificial chemicals, and when they burn, some of them degrade and form comparatively lower chain organic compounds, which are really hard to degrade, thermally speaking, and biologically as well. So that is why they tend to remain in gaseous phase, and we have to then afterwards install other air control measures to get rid of these components. And this is also an important question that I expect, that important and easy as well, that may come in the examination. The next question is for handling hazardous and medical waste. Which option will you choose? Your options are composting, rotary kiln combustion, AD is anaerobic digestion, and D is all of the other. Yes, option 2 is the correct answer, obviously. Then moving to question number 7. So SO2 is there in the flue gas of incineration plant, and how can you get rid of it? Yeah, these are your options. So scrubbers are basically used because cyclone separators, they are for solid particles. Baghouses is also for particulate matter. Electrostatic this precipitators, they are also for particulates. Scrubbers, they are used for gases, and yes, they can also get rid of particles, but specifically they are meant for gases. If you add some scrubbing unit, you can get rid of H2S, CO2, NOx emissions as well. And then later on, the wastewater that is generated from such scrubbing units, they are to be treated later on. And people use for scrubbing, people can use water there, sometimes also use alkaline liquids like let's say calcium hydroxide based ones, you dissolve lime in water and then you pass through such gases, because then if there is something like sulfur is there, then I think it will get converted to calcium sulfate and then get dissolved in water, which can be later on precipitated as well. So that is why scrubbers are important. Now moving to question number 8. Which of the following is not an advanced thermal treatment technique of solid waste? SW is solid waste. So your options will be gasification, pyrolysis, plasma systems, or mass burn. Like, which of the following is not an advanced thermal treatment technique? So in this particular question, you can see that yeah, plasma is an advanced one, because if you look at it from advanced here, what they are trying to say is that basically, if you look at incineration or combustion, they are the traditional or generalized ones. Pyrolysis, why is it advanced one? Because for pyrolysis, you need to have an inert atmosphere, for which whenever you are thermally treating a material, there should be a flow of nitrogen or any other these noble gases, so that there is no oxygenating atmosphere. For gasification, there should be partial oxidation, should be the oxidative atmosphere. For at the same time, the temperatures are very high, usually above 700 degrees centigrade. And plasma systems, they are even higher, because plasma itself, it is I think above 10,000 degrees centigrade of temperature. So these are all specialized and advanced techniques. When we talk about mass burning, these are like common in incinerators or in kilns. In those places, mass burning occurs. You can add in the agricultural residues. You can add in the these municipal solid waste or some other dry waste. So that is why mass burning is not an advanced thermal technique for solid waste management. So moving to the next question. This is a true and false type. So is it true or false? Yeah, it's true, because basically ash is containing only the leftover alkaline earth metals, and some other metals can be there, so they are basically non-biodegradable because carbon is not there. So let me see if I have any slides on it. This is one incinerator based slide. I think you can see here that combustion from temperature point of view occurs between 800 to 1100 degrees centigrade and requires excess amount of air, the question that we have just addressed few slides ago. Retention time should be 0.1 to 2 seconds for gases and liquids. And solids, since they take more time to combust, so the detection time is more. Then whenever you are adding any solid waste or any other product, the charging rate, it should be controlled, because if you add in too much, which is quite obvious, material, then incomplete combustion will take place, because there will be a lack of oxygen as well to combust that amount of mass that you are sending in. Then continuous ash generation is also there, which is usually non-putrescible. Then obviously such high temperatures, no living organisms will exist. And the ash is also inert, it doesn't react in any way. And let me see if I have any other flue gas based. This we have already discussed. Okay, so that was it. So the correct answer here is, as you have mentioned, it is true. Now moving to question number 10, which is an assertion and reasoning based one.
I have a question.
Yeah.
For inorganics, what is the method of getting rid of those wastes?
For inorganics, do you mean to say a waste which also contains inorganics, or just the pure, like, complete inorganics?
Inorganics, the waste which contains like glass, metal.
Usually,
So,
if yeah,
yeah.
usually if we have glass and metals, these things, the most preferred option is not to burn them or anything. The most preferred one is to recycle them, because they are valuable metals and other materials. So people usually recycle glass and metals. So we don't send them to combustion unit. We send them to other recycling units where, for example, you have iron in your this what let's say waste stream. So we use like very strong electromagnets. You have got different mix of metals on a conveyor belt, and it is passing through designed path, and somewhere in between you have a electromagnet. So all the iron that is present there, it will get stuck in that magnet, and later on from there you can retrieve the iron. Similarly, if you have some waste wherein you have got very small minute components, particularly in, let's say, electronic waste or something like that, then we have got specialized chemical, thermal, and in fact cryogenic techniques which occurs at very high temperatures. So there what happens is that you have got a mix of waste, you first dissolve them in a very strong acid, then after that, based on the individual metal chemistry, you try to separate it out from those. Otherwise, if you have things like glass is basically silica, or any other material which has got huge quantity of silica. Particularly speaking, in terms of glass, people usually separate glass right at the beginning, in developed countries at least, or in fact in India also, we try to separate glass manually when it reaches the material recycling facilities. So we don't put it into incinerators, because if you put glass into an incinerator, it has got no calorific value. The entire mass of it will become an ash, and then it will be again a nuisance to get rid of those ash. So that is why we don't put glass into incinerators, or metals. In fact, we don't put them into incinerators. They are separated out in different techniques are there, which are uh, currently in practice to move them into other streams.
So if it's a broken glass, it wouldn't even get recycled. Like, what will happen? What will be the usage of it?
No, if there is, for example, a broken glass is there, you can crush it, and then you can mold it again. So
Okay.
that is one way. Another way is that glass is basically silica, and silica, it is having its use in various other industrial applications.
Mm-hmm.
Silica is used as a support, like for the preparation of catalysts, and those catalysts can be used for preparing various petrochemical products, various kinds of other chemicals and all. So that makes a very useful component of a catalyst, silica, because silica is basically, it is having huge thermal resistance, not thermal resistance, it is thermally stable up to very high temperatures. For example, you are going up to a temperature of, let's say, 1000 degrees centigrade. Metals, they will start to lose their structural integrity, but silica won't, because that is their tendency. So then those silica, they can be processed later on and converted into various other useful materials, which can be silicon carbide as well. So these kind of stuff can be used for post processing of glass which have been broken and can't be again put into the recycling stream.
Okay. And one other thing, like these days we have observed that instead of packaging material being used as plastic,
Hmm.
it's a preferred way to either use glass or maybe metal in some cases, like steel, etc. So if we do an LCA of this, so what do
Hmm.
you think is more appropriate an approach? Because plastic can still be burnt and it has a calorific value, whereas
Hmm.
glass and others have to be recycled certainly.
Yeah, so in that sense, if you are speaking, like, glass has its own advantage and plastic has its own. As you said, plastic can be recycled and also it can be burnt, having calorific value. But glass in that way, it is having a huge, like, comparatively, I think, if you look at higher temperatures or if you put a glass outside your home at sunlight, you won't see the problems like we face with plastic bottles, like we hear microplastics and all those stuff. So in that sense, glass can be great alternative, but the only disadvantage that it faces is first thing, it is very brittle, and second, it has got mass. So these two things, they limit the commercial application of glass in place of plastics. So if you do an LC of these in terms of storage material, so then you have to also consider a certain lifespan. Then it will be useful.
Okay.
Apart from it, glass and plastic.
Because actually it's pushed positively that we should be using glass over plastic,
Hmm.
but while going through the course I had a feeling that probably plastic is equally usable if I look at in terms of the end of the life cycle, because I can convert that into energy, whereas
Yeah.
handling glass might be much more difficult for me. Reason being, it has to be very carefully separated and then has to be dealt in a proper way.
True, that is why plastic is more prevalent. The only, like, one of the major disadvantages of plastics, two of them to be precise. One is those single-use plastics. They can't be recycled because it is very difficult to separate them and then put them into a recycling stream. So recycling of single-use plastics, that is a huge challenge. Secondly, the management of plastic waste. Usually we drink those cold drink bottles and there is a particular supply chain that is there at place to handle those and reuse again those bottles, and various other processes are there. The same thing is not there for plastics. They are mismanaged much more than what is done with glass. So that is one challenge.
Okay.
Otherwise, you have correctly mentioned, like, glass has its advantages, but due to its cost and other practical problems, that is why people used to go for plastics. That is something.
Okay. Got it.
Yeah.
Thank you.
Yeah. Now the next question is again assertion and reasoning based. So the first statement is volume of SW solid waste remains intact after incineration, and reasoning is waste to energy WTE for solid waste management. So again you have got same options like these. Okay, so option one is not the correct answer, because when we go for incineration, what it does is drastically reduces the volume. So option this A assertion is not correct. Incineration is one of the WTS methods. This is correct. What happens, as you have seen, that during incineration or when we thermally treat a material, we first characterize it to see its components, wherein we see what is the fixed carbon, what are the volatile matters, what are the inert is there, how much your what to say moisture is there, then something non-combustible part is there, or ash is there. So this is how we first look at a waste before putting it into incinerator, because that is how we have to go through if we want to make the incinerator function in a economical way. So when we put those things inside, then what gets rid of the entire mass or the volume? The moisture, it is driven off. Then the volatile matter, which is also quite significant if you are burning, let's say, any biomass, agricultural residues, then you will see that the volatiles present there, it can be as high as 50% or even more, 70% also. So 70% of it is volatiles which are driven off completely. So they some about 40 to 50 or in fact more of the volatile matter they are driven off, so that much volume is removed. After that, you have got moisture which is removed first, so that volume also gets rid of. Then you have seen the among the four phases of combustion, the remaining fixed carbon that is also burnt off to form carbon dioxide and other gases. Finally, what remains behind is the ash. And if you look at it based on different waste streams, the ash content it is usually less for as compared to municipal solid waste. The ash content is less for these agricultural some of the agricultural waste streams. It can vary. For example, in sugarcane bagasse, if you are burning it, and what happens in your sugar mills, the sugarcane comes in, then the juice is extracted. After that, it gets processed, and in the meanwhile, sugarcane bagasse is generated. Basically, the one that is left over when we get sugarcane juice. So, what sometimes people do is that they burn it in boilers, and the energy that they derive from it that can be used to as a heat or for production of electricity. So, those sugarcane bagasse, when we try to look into it, you can see that around 70-60% of its volatiles, and ash can be I think around 20% or something like that. Just let me see, I have one information on it to be more precise. Give me a moment. Yeah, so sugarcane bagasse it is having very less ash. I think less than 5% also. Most of it is volatiles. It is more than how much 80%, more than 80% of it is volatiles, and the rest is moisture content. Around how much it is, 10 around 4-5% is moisture content, the dried one. So that much mass can be removed or volume can be removed when we put such materials into incinerators. So that is why volume of the solid waste it reduces drastically after incineration. Now moving on to question number 11. So in a double liner landfill system, what is the thickness of compacted clay? All the options will be in feet only. Okay, so option B, that is 3 feet, that is the correct answer. I will show you the figure as well of both the double and single liner. Here you can see that in double liner, the top drainage material that should be 2 feet. It is same for both single composite and double liner systems. Then the head, basically of the leachate, that should also be less than 1 feet for both double and single liners. Then after that, the compacted clay, which is at the bottom of the compacted soil, you can see that is 3 feet depth for double liners and 2 feet for single liner, single composite liner. And in between, you have got in double liner systems, you have got a layer or a sandwich of HDPE geomembranes, and then in between there is a geonet. This geonet basically it helps in lateral movement of the leachate, and it also helps in detection of the leachate or any leakage. If there is any leakage of this HDPE geomembrane, then this geonet it allows the leachate to flow in lateral direction, and it can also be detected in that way. So you can take suitable measures to rectify the leakage at a certain point. And in the single liner system, there is no such geonet present. There is only an HDPE geomembrane present there. So this was question 11. Then moving on to question 12. SW is solid waste. Yeah, very good at question this one is, and quite conceptual as well. So during heating a solid waste and splitting its organic components by thermal cracking and then condensation, these things are done in which of the following processes? Option 4. No, option 4, if you look at these options, you will find that option 4 is pulverization is basically you are grinding it to complete fines. That is what pulverization is. It's not a thermal process. Other than that, gasification is there, incineration is there. Let me see one. So if I go with the particular definition of pulverization in Google, you will see that the process of pressing or crushing something until it becomes powder or soft mass, that is what pulverization is. And now taking a look into other processes, that is gasification. During gasification, again, partial oxidative environment is there, and the main thing is the products are in gaseous phase. So it is very difficult to condense them in the this ambient conditions, and that is also not the goal of this gasification process. Basically, they provide you this gas stream which has got high energy content. Then incineration comes. There also the gaseous or the flue gas that is generated. These are mostly carbon dioxide, monoxide, H2S, NOx, and SOx emissions are there, which are also not possible to condense. But in pyrolysis, what happens? It has got three major components. One is based on the type of pyrolysis, slow, intermediate, fast, or medium. Based on them, the products can vary. Like the pyrochar is one of the products, the pyrolysis oil is one of them, and the pyrolysis gas is another one. So in pyrolysis, what happens when the organic material, let's say plastic, thermal cracking takes place basically at high temperatures, the bonds are broken. So in those instances, yes, some of the non-condensable gases like CO2, CO, H2, CH4, and few other gases, such non-condensable gases, they are produced. But at the same time, a lot of volatiles are produced, which can be high molecular weight alkanes and alkenes, which can be condensed later on, and they are often denoted by the name of pyrolysis oil or sometimes tar as well. So they can be later on condensed and reused again. And it is very vital, in fact, to get rid of them before further use, because what happens is that when we do pyrolysis, if those condensable materials are not segregated beforehand, and you carry those condensable materials along with the important gaseous product, so these things they can start condensing on their own when you move them through pipelines under ambient conditions, and they start getting stuck on those pipeline surface. And then in fact there's a possibility, based on their acidic nature, they can start corrosion of those pipelines, and the blockage of pipelines, that is another issue. If you're using some transparent pipes and something like that, then you will see a deposition of such yellowish kind of layer, dark yellowish kind of layer, or blackish layer. So these things occur, and they need to be, the maintenance is then another challenge. So it is really important that if there is such process where, like pyrolysis, where the condensable volatile matters are generated, it should be condensed and removed beforehand. For in general way I am speaking, but for if there is some specialized process or some specialized application where that is necessary, then it will be a different issue. So that is it. Moving to question number 13. The answer of this particular question has been discussed in one of the previous slides as well today. All the values are in degree centigrade. Okay, so the correct answer is option D, that is 800 to 1100, because in 300 to 500, that is not the ignition. There is something, na flaming, flame point, flash point, those stuffs are there. So based on those principles, 300, 500, they won't work. So in an incinerator, the insulator temperature is 800 to 1100. And you can see that somewhere here in one of the, here in ideal incinerator, you can see that the first point is combustion temperature. It is between generally 800 to 1100 degrees centigrade. So this was question number 13. Then moving to question number 14, which is a very important question from examination and conceptual perspective. And your options are, oh, yes, absolutely correct. Turbulence is basically mixing of the waste material with air, and the other two T's are time for burning and appropriate temperature for burning. So I think I have a slide for that as well. Yeah, this one is three T's: temperature, time, and turbulence. Temperature, it should not be less than 790, because if we do so, various odorous compounds can be released, and greater than 980. At those temperatures, some dioxins, furans, and VOCs are released, which are very difficult to be controlled by the air pollution control systems. Then here you can see that the high temperature, that is 800 to 1100, it should be such that the ignition temperature is reached, those flash points and all, fire point. Then time, you should provide enough time for complete combustion. Then turbulence, the one that we just had in this particular question. So moving on to the next question, which is also the final one. Okay, so these are the options. Which of the following is not true for the solid residue generated during thermal treatment of waste? One or two, okay. So one is basically option one is the true sentence because plasma the temperatures are so high that everything gets like all the bonds are broken and everything is converted into mineralized forms like CO2, carbon, and all those stuff. So there's a very almost negligible solid residues present. But the downside of plasma, because why do we don't go for such processes? Because then we won't be facing the problem of managing the solid waste. Because since the temperatures are very high, we have to put in a lot of energy, which makes the process often uneconomical. The second option, that is the correct, that is not true, because you already know that government has mandated a long time ago that we have seen that when we construct our homes or any other material or buildings or dams or anything, use fly ash there as a certain percentage as a, I think it is a binder or filler material, something like that, in concrete. So there we see the fly ash being used as a construction material. So that is why we have seen this from our childhood and in our college as well. The ash from conventional combustion, they can be used as a construction material. So that is why option 2 is the correct option. So these were the questions today we had, and I will quickly go through them again. So starting with excess combustion of solid waste is done. Why? What is the reason? That is done to ensure complete combustion of the process. That is why we often use 120 to 200% of air, which has been calculated based on the stoichiometric requirements. So we take 1.2 to 2 times of that air. Then leachate is a colored liquid which comes out of, if you have only these four options, choose sanitary landfill, but for your knowledge, it can come out of both sanitary landfill. Usually we study more about sanitary landfill leachate, but it also comes out of compost plants, because in sanitary landfills, talking about that first, rain occurs, it leaches down, seeps through all the waste, various organisms, they starts getting dissolved in there. If some gases are produced, they can also get a certain portion of it, it remains in the liquid form, dissolved in the aqueous form. Then, since the pH of the leachate it can be low, so certain metals they can also get dissolved to some extent, and then they starts forming a very dark colored and gets collected at the bottom, and is very hazardous, is very dangerous, and can be really detrimental to the environment if you dispose it off careless. So that is why there's a separate in sanitary landfills. There's a separate section for handling, treatment, and then disposal of this leachate. In compost plant, what happens, like we have to spray water at after certain intervals to maintain the optimum water moisture content. So some 10 portion of it, it starts to leach through the composting material, or sometimes it itself loses some moisture. So that can, if there is initial moisture content high, that can also leach out. So in those instances, the leached out material or composting leachate, it can also have huge COD. And since based on the type of material used for composting, the constituent of that leachate can vary. If you're using food waste, then chloride ions will be there more, because sodium chloride is used in all the dishes, so that its presence you can clearly see there. Other than that, the organic loading can be high. That is another. So moving on to the next question, which of the following is not one of the four phases of combustion? Herein, the condensation of vapors, it is not a phase of combustion, it is entirely a different process. When I'm talking about the phases of combustion, then you have got starting phases where the moisture is driven out. After that, the volatiles are removed, whichever that phase is called volatilization, then burn down of solids occur, and finally, the char that is there, it gets burned. So in the next question, assertion and reasoning based, you have to go through this slide to get a more detailed idea and the teaching materials that have been provided to you. A fixed hearth is stationary, the name itself suggests. Rotary kiln, it rotates, the name itself suggests. A fixed hearth, it has got a single chamber, while the rotary kiln has got two chambers. Although both the statements are correct, but unfortunately, option that is R is not the correct explanation for A. Then in next question, the flue gas from the incinerator stacks, it includes all of these above: hydrogen sulfide, carbon dioxide, monoxide, mercury. Based on the kind of material that is being disposed, there is certain mercury present is there, then you will see mercury in the gas as well. Then handling of hazardous and medical waste, these are done through combustion in rotating kiln. In our campus also, the sanitary napkins that are produced at hostels, they are also incinerated at the allocated points. That can be in hostels or sometimes near a composting plant. Also, there is a small incineration unit where the sanitary napkins are being disposed and incinerated. Okay. So after that, we have got you have to remove sulfur dioxide from the flue gas in the incineration plant. What will you go for? You will go for scrubbers, because the cyclone separators, baghouses, and electrostatic separators, they are basically used to get rid of the particulate matter that are present in the flue gas. After that, you have got the you have to choose an option which is not an advanced thermal treatment technique. Here, and the correct option is mass burning, because if you look at gasification, pyrolysis, and plasma, they are all advanced techniques because they have their individual very process specific requirements, and you really need to have skilled labor to monitor such processes to see that whether suitable or appropriate conditions are being maintained or not. While mass burning is, as the name itself suggests, it is simply mass burning as occurs in incinerators or in some of the waste energy plants, the simpler ones. Then ash, we know it is non-putrescible in nature and it doesn't decay over time, the incinerator ash, so that statement is true. Then in incinerator, the volume of solid waste, if you have got a statement which says that the volume of solid waste remain intact after incineration, it is completely wrong and absolute opposite, because incinerator what it does is that it drastically reduces the volume of waste, and at the end what remains is the ash. So that fraction is much smaller than the initial solid volume of the solid waste that you had taken. And the second statement is incinerator is one of the waste to energy methods for solid waste management that we already know, that the generated heat that can be used for different processes or for producing electricity as well. Then in option this question, the double liner system, it has got a thickness of 3 feet. Again, I will show you the slides which will help you to remember. This is the thickness. In double liner, it is 3 feet, and in single composite liner, it is 2 feet, both of which should have a permeability of less than 10 to the power minus 7 centimeter per second. Again, what distinguishes double from single liner is you can see that in between you have got a sandwich of HDPE geomembrane and a geonet, which is not present in single composite liner, where you will see only a single HDPE geomembrane. So these are the basic differences. Then so heating of solid waste means splitting its organic substances by thermal cracking and condensation. It occurs during pyrolysis, because after pyrolysis, the pyrolysis oil or tar that is generated, it is collected through condensation of those cracked volatile materials. Then after that, we have got the ideal incineration temperature, which should be about 800 to 1100 degrees centigrade. And then the three T's of combustion: turbulence, temperature, so appropriate temperature and appropriate time it should be given for burning. So when I am talking about turbulence, it means mixing of waste with good quantity of air so that there is a complete combustion. Then which of the following statements is not true for solid waste generated during thermal treatment of a waste? In here, the most obvious one is ash from conventional combustion cannot be used as a construction material. That is wrong, because civil engineers, we have been taught, we have seen, like in every construction, not only the civil engineers, any person, if you go to a construction site, you will see that while preparing a concrete, people mix in aggregate, fine aggregate, coarse aggregate, and then they also put in fly ash, which I think acts as a binder and filler material. I think binder it acts. So fly ash is basically it is a component in almost all the construction processes, and it is also mandated by the government use fly ash because that is also a way of solid waste management. So these were the questions that we had today. In the next live session, the next coming Monday again, we will be having our week 9 live session. So in case if you have anything to discuss, you are always free to unmute yourself and share that. Otherwise, we will meeting next Monday.
Nothing from me. Thank you.
Okay, welcome.
জয়, তোর টিকিটটা এখন বুক করে দিচ্ছি। कहाँ जा रहे हैं सर? मतलब अक्टूबर, हाँ, वापस आते वक्त कितने बजे रात को है? वही कैसे अरे इधर থেকে চাবিটা নিয়ে নে আমার এটা 5 মিনিট বন্ধ আচ্ছা আমি নিয়ে আসছি क्या हुआ मजा लो जल्दी जाके सो जाना एग्जाम से पहले जो है ना कम से कम 8 घंटा समझ करना चाहिए ना मैं तो एग्जाम में खुद सो गया पिछली बार जब मेरा मेडिसिन था वो भी सबसे टफ सब्जेक्ट था ना तो उससे एक दिन पहले सुबह 9 बजे से मेडिसिन था और मुझे एक दिन पहले जो है 2 बजे अपनी बर्थडे पार्टी में रात शाम को 8 बजे से लेके पूरा 12 साढ़े 11 बजे तक मैं वहीं पे था फिर आके थोड़ा पड़ा सर हम लोग खेलना नाइट्रोजन करेंगे